today we are looking at inscribed angles of circles. You should also have a protractor, which is on your way in when you came in. So what I want to do is I want to take this circle down here and mark the center as best as you can. And then I want to go ahead and just make a central angle. So that just means an angle that goes through that point I just marked. It can be any size. Then it wants me to construct the corresponding inscribed angle. So that means I just pick a point over here. And then for my points A and B, I go ahead and connect them. Okay, so then I want to measure both angles with my protractor. What I want to do is, I look right here in the middle, there's a little up and down tick mark. That's where I want to align my center and one of my one of my lines. So if I am looking at the ACB angle, I want to line up the black tick mark with the C, and the black line down below I want to line up with my V. And then it looks like this angle is about, it's a small angle, so I picked the smaller of the two numbers. This one looks like it's about 60 degrees. I'm going to go ahead and do the same thing for my ADB. So I have the tick mark lined up with the D, the black line lined up with the B, and then this one looks like it's about 30 degrees for me. Your angles might be different because you drew this by hand. But there should be a pattern here. So the inscribed angles theorem states that the measure of an inscribed angle, so that is this angle right here, is half the measure of the intercepted arc. So notice, this 30 degrees is half of the 60 right there. So these want me to find the measure of the indicated arc or angle. So this angle needs to be half of this 124. So I'm just going to do 124 divided by 2. Which gets us 62 degrees. So then this next one wants me to find the measure of arc GI. This one matches the angle, so it's just going to be 139. And I can tell it matches the angle because it goes through my center. on the next one, I know that the square means that it's 90 degrees. And so I want to find the measure of this arc right here, VZY. So this one is working backwards. I know that this one needs to be twice as big as that one. So I'm going to do 2 times 90. So for this one right here, I have that this angle is 162, so that means the arc LM is also going to be 162. So to find angle LOM, I want to take the 162 and divide by 2. Which gets us 81. So this one, HKI is telling me that this is 25. So that means that arc HI is 2 times 25, which will give me 50. But that's not what this question is asking me for. It's asking me for angle HJI. So it's really asking me for this angle right here, which is going to be half of that 50, which is also 25. So notice, when I have two inscribed angles. When I have two inscribed angles that end at the same place on the same arc, they should be the same measure. And then number 4 wants me to solve for x, so remember this tiny angle is half of this one. So I can do 2 times 2x minus 1 equals the 5x plus 2. So I distribute that 2, I get 4x minus 2. Equals 5x plus 2. So I want to subtract 4x on both sides. I have negative 2 equals x plus 2. And if I subtract 2 on both sides, I get x equals negative 4. Then I have the inscribed right triangle theorem. So if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. So on number 5, because AB is the diameter, I know that angle ACB has to be 90 degrees. So I'm going to set 2x equal to 90. And then I divide both sides by 2, and I get x equals 45. So on this one, angle A is across from the diameter, so A is going to be 90 degrees. C is an arc measure, so I know that from here to here has to be 180, and I know that this part right here is 124. So to get C, I'm going to do 180 minus 124. Which gets us 56 degrees. And then since B is my inscribed angle, I know it has to be half of 56. So I take 56 and divide by 2 to get 28 degrees. Okay, a polygon is inscribed. That just means drawn inside when all of the vertices lie on a circle. Okay, so all 3 of these are inscribed. If I had something like this is not inscribed. Because that third point of the triangle isn't touching the end. So my last theorem for today is the inscribed quadrilateral theorem. If a quadrilateral is inscribed in a circle, opposite angles are supplementary. So what that means is the measure of angle A added to the measure of angle C should give me 180 degrees. So if I add these 2 angles together, they should add up to 180. And the same thing should go for the measure of angle B added to the measure of angle D. Okay, so down below I want to go ahead and solve for A, B, C, and D. Let's see. So let's start off with C and D since they're on the inside. C should be added to 108. So I have C, or not 108, 102. And it should equal 180. I go ahead and subtract 102 on both sides. I get C equals 78. Then I can do the same thing for D. So D is across from 92, so I can add those two together and set equal to 180. So I subtract 92 on both sides. I get D equals 88. Okay, so then I need to go ahead and find my outside arc measures. So I have this 92 right here. It's going to measure up with this arc right here that I just drew in red. So if I take 2 times 92, it should equal this 140, and I'm going to make this a letter X. So I can add to that. So 2 times 92 gives me 184. And if I subtract 140, I get that X equals 44. So this piece right here is 44. Then I want to match up the C to this arc right here. So it overlaps with that 44 and the B. It's going to be 2 times my C angle, which was 78. And that's going to be 44 plus B. So 2 times 78 is 156. And then I subtract 44 to get 112. Oops. Okay, and then I just need to go ahead and find A. So I know 3 of the 4 measures on the outside of the circle. So I can say that 360 minus those 3 angles are going to give me my A value. This gives me 64. Okay. I can go ahead and solve for Z on the next one because it's across from 93. So Z plus 93 should equal 180. I get Z is 87. Then if I take a look at x, this angle is inscribed and it matches up to these two arcs. So if I take 2x, it should equal 58 plus 106. '58 plus 106 is 164. And then I divide both sides by 2, and I get 82. So now that I know that x is 82, I can find the angle directly across from it. So I know that 82 plus y should equal 180. And then I subtract 82, I get y equals 98. On the last three, I'm solving for my variables again. This one is a right triangle because km is a diameter, so that makes x equal 90. And then to solve for y, I just do 180 minus the 90 minus the 40 because it's a triangle, which gives us 50. For number 5, I can use diagonal angles to solve. So y plus 68 should give me 180. If I subtract 68 on both sides, I get y equals 112. And I can do the same thing for the x and the 82. So x plus 82. Equals 180, subtract the 82, I get x equals 98. Okay, and the same idea for number 6, even though I only have variables, I add the two angles across from each other, so 8x plus 10x. And this should equal 180. So that really gives me 18x equals 180. And then I divide both sides by 18. I get x equals 10. And then I do the same thing for my angle S and my angle U. These ones have C's, so I have C plus 2C minus U equals 180. Combining like terms gives me 3C minus 6 equaling 180. Adding 6 to both sides, I get, I'm going to go over here, 3C equals 186. And then I divide to get C equals 62. C equals 62.